Hi, welcome to my lab. This is another aircraft instrument. This time it is a vintage radial magnetic selector. So the serial number 4269-66. You can see the reference and the code. On the rear there is the typical circular connector. There is the manufacturing date here, 1971. On the front there is a compass card. There is an index and an indicator. This is the radial selector for the VOR. And there is also a needle in the center here. This indicates maybe the direction of the VOR station. So let's open this thing to see what is inside. Okay. The smell of this thing is very strange. It smells the very vintage stuff. On the rear there is the electronic side, where we can see two power transistors. Difficult to see the reference, the CV7085. The date code is 67. These are obviously germanium transistors, probably an equivalent of the OC28. In the past it was widely used in avionics. You can see a small toroidal transformer here. This seems to be a castanet tantalum capacitor. These two diodes are probably used for rectifying. And there are also two other transistors here. The electronic circuit is probably used for a servo control loop amplifier. So we can find a synchro resolver, sine cosine here. Okay, so this is linked to the radial selector here. This is normally a sine cosine which works at 30 Hz for the VOR feature. There is also a synchro control transmitter. There is this small AC motor. It's called the servo motor. This should be linked mechanically to a synchro transformer also. I don't know which one, because this motor rotates these reduction gears. The result is this gear here, which is linked to this shaft. There is a differential gear. You can see here. I would like to connect this instrument to the compass indicator. So I would like to find the servo control in order to drive the compass card. So the motor is here. Normally this should be this one. Okay, you can see the rotation of the compass card. The motor is probably connected to the amplifier. These two power transistors should be the output stage. We can see that the synchro resolver and the synchro transmitter are linked together, and actually they are linked also to the OBS, the omni-bearing selector here. So normally these two synchros will be connected to the rear connector. On the front there is this AC motor, as we have seen. This motor is linked to the compass card. Then there is this synchro control transformer, which is also probably linked to the AC motor. It is difficult to see because of the high reduction. That I can see effectively a rotation of this synchro transformer when I rotate this gear here. Okay, so the servo control amplifier is connected between the rotor of the synchro transformer and the AC motor. The stator should be available on the rear connector. Okay, and we can see that the last item here, it is difficult to read, but this is the torque receiver, synchro torque receiver. So this is probably used for the movement of the needle here. So this should be connected directly to the rear connector. Okay, so everything is here. So I didn't see, but there are two transformers actually. One small, here we have already seen, and this one also. So what I will do is that I will apply, as usual, an AC voltage on the secondary side. So one secondary side is obviously connected to this rectifying diode. So I will apply an AC voltage between the anodes of these two diodes, and I will search for an AC voltage on the rear connector. So this will be the first step. So this is an AC power supply, 15 volts, 400 Hz. So I will apply this voltage across the two anodes of the rectifying diodes. It is difficult to access to the terminals, but should be okay. I will increase the AC voltage because on each secondary the voltage is half this value. Okay, the voltage is now something like 20 volts AC. I can hear a little noise at 400 Hz inside, probably a synchro transformer or maybe the AC motor. I will search for an AC voltage on the rear connector. I will use my personal method. I will connect one terminal of the DMM to the chassis of this instrument, for example this hole here. Then I will search with only one wire an AC voltage on the rear connector. The DMM is set to 100 volts AC. Okay, so there is a voltage here of 7.4 volts. This is the highest voltage I found. Okay, so I will connect this terminal to the DMM and I will search for the other terminal. Okay, so there is a voltage of 28 volts AC. Okay, so we can see that two terminals of this AC motor are connected together. There are these two terminals here. So obviously these two terminals correspond to the reference winding of the motor. And we can see that they are connected to the 26 volts AC power supply. This one and the other one. So it seems that the power supply of this instrument is 26 volts AC. The two control windings of the AC motor are connected to these four terminals. Two are connected together, as I said, to normally the power supply. And normally the other terminal should be connected to the collector of the power transistor. So for example, this one is connected to this transistor, this one here. And let's see the second one. Okay. So now we need to find the corresponding windings of the synchro transformer, which is this one here. One solution is to use a needle like this one and to penetrate into the insulator of the wire. It is difficult because generally the insulators are made with Teflon and Teflon is very difficult to pierce. Okay, so I will use this needle. It is possible to use 4 mm bananas plug and to insert into it like that, and then it is possible to penetrate into the insulator. So there are 5 wires on the synchro. So the red is always the rotor, as it is used for the servo control loop. The rotor is connected to the input of the error amplifier. So we just need to find the corresponding pins to the stator, which are these 3 wires here in the black tube. So let's see if we can penetrate the insulator. It is not easy. I have found 1 pin which corresponds to the red wire of the stator of this synchro. This is this terminal here. And I have found also the 2 other terminals. Generally they are close together, so when you have one, it is easy to find the 2 other ones. We can see that there is a resistance of 25 ohms between each pair of terminals here. So what we can do now is to connect the synchro transmitter to these 3 terminals and see if you have a rotation of the compass card. So let's do that. Okay, so I have connected this synchro transformer to the stator of the synchro transformer, which is used for the servo control loop. I have connected the rotor, of course, to the 26 volts AC power supply. So let's connect the power supply here to the 26 volts AC. It can work, or maybe it will not work. I don't know. Okay. So this works. So you can see that it is not complicated to make working an instrument like that. I think I spent 1 hour since the beginning of this turn on, something like that. You can check if it is also possible to connect the synchro transmitter in order to rotate this needle here. So we can check if we need to provide another reference voltage for the torque synchro here. So we check if there is an AC voltage. Okay, so we disconnect the power supply. I will note the pin out for the compass card. So the power supply is on the middle. It seems to be terminal T, difficult to see. Now the center is T and this one is R. Okay, so R and T. Okay, and the stator N, M and small f. Okay. Then we can search for the connections of this torque synchro here. So the connections are accessible, so this will be much easier. Okay, so I think I have found the stator, which is somewhere here. Okay, so there is a resistance here of 4.5 ohms, here also, and here also. So these 3 terminals are connected to the torque synchro. So we can try to connect the synchro transmitter. Okay. I don't know if the rotor is connected to the 26 volts AC, or maybe we need to provide also the supply for the rotor. I don't know. Okay, so first I will connect the power supply for the indicator itself. Terminals R and T. So you can see that there is no action. As you can see, a little movement, because actually the stator is supplied but not the rotor. Okay, so we just need to find the connections of the rotor of this torque synchro. Okay, so I have found the rotor of the torque synchro. So I will connect these terminals also to the 26 volts power supply. Okay, I have connected this synchro transmitter to the torque synchro, and we can see that now it works. So now I will connect this instrument to the gyro compass I have tested in my previous video. I have connected the synchro output of this compass indicator to the input of this one. So this one is used as a compass repeater. As you can see, these two indicators work perfectly together after 50 years. Thanks for watching and see you next time for another instrument. Bye bye!